I've been accused of many things in my life, and being a lazy programmer is probably one that I will never object to. If I can find some way to have somebody else write code for me, that's the way to go. And one of the things that's really wonderful about programming in Python is not just is there so much out there, if you look on the web for how did somebody solve this problem, there's so much that's actually provided as part of the language. And one could probably spend just a couple weeks talking about all the different things that are built into Python. I'm not going to try to do that. I'm just going to try to spend half an hour at most talking about what's there and how to go looking for it and how to use it. So I'll start by talking about a little bit about built-in routines. Then we'll talk about standard modules and how you access those modules. We'll talk a little bit about other stuff, some of which we'll cover later, and then how you get to that stuff. Okay, so what can Python do out of the box? A lot of stuff, okay? It has many useful libraries for doing things like interacting with the operating system, mathematics, simple mathematics, and the developers of Python are very happy to add more and more capability to the language. So I gave you an example when we were talking about data types of sets. A set was a very useful concept. When the developer saw it and saw that the code was clean, they are very happy to pull it into the language and make it part of the language. So you can expect to see the power of Python keep growing over the years. But in addition, and this is something we'll be talking about more and more, there are many libraries out there of things that Python will do that are not part of Python, may never be officially distributed as part of Python, but are really extend the capabilities of Python tremendously. So what can Python do out of the box? A lot, and even more if you use a distribution that gives you other things that look like they're part of the box. Okay, so there are a total of 80, at least in the last I looked, built-in functions in Python, and we've seen a few. Range, which we just used in the homework, is an example of a built-in function. You just call it and it's there. Length is there. Some of the type statements, complex. I think I showed you how to make a list using list rather than using the square brackets. I went through the list and picked out the stuff that I think you're most likely to want to use. Absolute value, well, that's a common one. Any is sort of useful. If you give any with a list of item, a tuple works fine. It goes through and it comes back with true if any element in that list is true. So it's or the first element or the second element or third element or the fourth element or so on. That's something that you find yourself using from time to time. All is the equivalent where you use and. So it's all will be true only if every element is true in the collection. Okay. This one we'll see more of use for when we start looking at modules. But if you say, let's say, actually, let me show you that. That's, I think, worth seeing. Let's see, do I have a Python shell? Here we go. So A is a string now. Okay, dir parenthesis A will show me all of the functions that are defined attached to my variable A. So I know that I can do a.count, I can do a.title, and so on. I may not necessarily know what they mean, although I can look that up by saying help a.title And then it brings me to some help information about that routine. And while I'm here, well, I'll come back to this actually. I don't want to get too far ahead of myself. I'll show you a little bit more about that. Okay. Okay, well, we saw DIR, we saw help, maximum, minimum. We talked a little bit about opening files, powers. Raw input is a way to, if you're writing a program that's running in a terminal or DOS window, raw input is a way to get a quick answer. Round is, we'll round a float into a integer or to a fixed number of decimal places. Sorted is something you can use to get a list that's sorted, and you have some parameters, optional parameters, that will tell you how sorted will work. And finally, we looked at this, but I'll just remind you about it. Zip takes a list and makes a list of tuples, taking where the first tuple will have the first element from each list and so on. So these are all useful things, which isn't to say that the ones that I didn't pick out aren't useful. If they weren't useful to somebody, they wouldn't be there. But I think these are ones that if you're programming in Python, you'll probably find yourself using most, if not all, of these from time to time. Okay, well, you want to do a lot more stuff than just that. And there are something like 200 different modules in Python that are distributed with the language. So if you just go to the Python website, download Python, don't ask for any other packages. Like you don't ask for NumPy for math calculations. You will get something like 200 modules. There's a link that gives you the documentation for all of them, but here are some ones that you're likely to think about using at some point. Well, math comes first. So that's where you'll find sine and cosine and things like that. One thing that a lot of people will end up doing from time to time is working with file paths. You want to you have the name of a file. You want to find out what its full directory name is, or you want to just strip off the directory so you know where to put other files based on the input file location or something like that. You can do all those sorts of things in os.path. There are going to be things that are specific to the computer you're running on, either because of its operating system or because of the way that particular computer was set up. That stuff is in sys. And I'll give you some examples. What if you want to know all the names of files that match some pattern? That's when you do dir star.star, that's known as globbing. I don't know where that word comes from, but I didn't make it up. And there's a package called glob, which will give you file name searching. There's lots of stuff that you want to do with the operating system. OS gives you that. If you've worked with regular expressions, I sort of have a love-hate relationship with regular expressions. I use them only when I have to, which means I use them from time to time. But if you understand regular expressions, which I'm not going to try to explain, they're a really powerful way of picking out information or testing for things, stuff like that. Pickle is a way to take some very complicated Python object and just save all of it. When you pickle something, and there's a faster version called cpickle, it just takes everything you've got, converts it to a character string, which you can then write out to a file and read back in. So it's a very quick way of saving state if you need to do that. If you want to know what time it is, you can get the time of date from time. Or if you want to manipulate time and date stamps, there's a package called datetime. Is there a question? Okay. Okay. If you want to do email, there's an email package. There's a debugger called PDB, which is not Protein Data Bank in this context. If you want to create a subprocess, this is something I find I do from time to time. I'm running Python up to a certain point. Then I want to go do something, either that maybe I want to start another process that will go do something and it will run independently. Maybe it's another Python process. Maybe it's a shell command. Maybe it's launching some big Fortran program that's going to take an hour to complete. You can do that in subprocess. And you can either start the subprocess and wait for something to finish and come back, or you can start the subprocess and let it run independently. This is something that I might show a little bit about, PyDoc. PyDoc is actually better thought about as something that you run externally, but you can use this to generate documentation. Sometimes when you're writing code and you really care about how fast it's going to run, there's more than one way to do the computation. You might want to see how long is it going to take, and this module time it can be used to run a bit of code and see how long it really takes, and maybe compare it with some other version of doing the same thing. So these are just, I mean, obviously there are many more modules out here, but these are ones that at least some of these I find I use all the time. Let's see. All right, so how do you get to stuff that's in the modules? Well, I hope that this doesn't mean that there's going to be a show and tell on EPEX interfacing, that I have to answer questions on how to hook that up with Python. Okay, so how do you get access to anything that's in these standard modules? It turns out it's pretty easy. If you want to use something that's in the sys library for the sys module, you just say whenever you're going to use it, import sys. And that's saying, give me access to everything that's in sys. But it does it, you only get those things by prefixing sys to this. So some of the things that you'll find in sys is a variable called platform that will tell you what kind of computer you're using. Sys.exit will exit the program. Sys.path, we'll talk more about what that is, but that's where Python's going to look for libraries. And so sys.path is a list, and lists come with append, so sys.path has the append command built into it, so I can append to it. What may not be obvious is what's going on is when you say import sys, sys is itself most likely a Python file. The first time you import something, that file is run. Any later time that you import it in the same Python run, all it does is it looks it up and says, oh, I've already run this, I don't need to do it again. Anything that's defined inside this library, this module, is there and it's accessible to us as long as we prefix it by sys. So now the trick is that when we start spreading our code into multiple files, we'll need to put an import sys in every code, in every file where we're going to access sys commands. But if our file doesn't need it, if one file needs sys and another file doesn't, we only need to put the import sys where we need it. Okay, and the important thing is, and this will be more important when we write our own and start using our own, is that the code in sys.py is only executed once. Okay, so one thing that's a little bit tricky is that I pointed to a package called os.path, and then later I referenced just the package called os. So we can, if we only want to get stuff that's in the sub package, the routines that are os.path.something, we can just say import os.path. And then it won't pull in everything that's in os. However, there are other cases where You'll only get the contents of a sub-package if you specifically ask for it. And an example of that is if you do an import SciPy, you don't by default get the special routines, which contains the Bessel functions, unless you specifically ask for to import scipy.special. This is confusing. How would you know? The answer is you don't. You just have to try it. It's probably documented in each case somewhere in the documentation, but I wouldn't be 100% certain of that. I can tell you why they do this, and that is that SciPy is really big, and it takes a little while to pull it in. So it goes faster because you don't pull in everything in whether you want it or not. This allows you to pull in just the things you want. OS is pretty small, so whoever was writing OS felt that there was no penalty in pulling in everything at once. But it was convenient to separate the path functions just by having them in a separate place. But it was really up to the authors as to how they organized their packages, which way it would work, whether it would work like OS, where pulling in OS brings in all the children, or whether you need to bring in the children as you need them. All right, so I want to point some stuff out because you'll see some of this, but I recommend you don't use it yourself. Well, first thing is, you may come across packages which have really annoying names. Okay, so here's a package with a long name, very originally named, and it's going to be really annoying to type package with a long name for every single call I'm going to make to something that's in that package. So here we can come up with an alias. Okay, so I can say import package with a long name as PWLN, and when I do that, I can choose anything I want here. I could just make that a P. Now I can say PWLN dot something. Now, by using this prefix, we keep everything that's in our package separate from everything else. So if you see a routine, foo, you can immediately tell, is that foo from my code or is that foo from some package because of its prefix. Now you can make an alias the same way we did here by variables can contain pointers to anything. So we can make a pointer to a package by just assigning a variable. So these two lines of code do exactly the same thing that this one does, except this defines both this package and that variable, while this one will only define this. Okay, so I could actually do the same thing with 3 lines if I wanted to. Import the package, PWLN equals the package, and then say delete package, and that would get rid of it. But and it's very common to do this. As a matter of fact, you'll probably find folks using NP as the name for the Python package NumPy more often than you'll see people writing out NumPy. But I really feel, having spent a little bit of time looking at code that doesn't have this, that it's really worth the time. Particularly, 3 extra characters, NP dot, is all the extra characters you're having to add. Yeah. Right. Right. Or there'll be no problem. So if I have a variable called platform, and I also want to access sys.platform, they're completely separate. Okay, one is just a variable called platform, one's a variable called sys.platform. There's no interaction. Python doesn't consider them anything like each other. We'll see in a moment how to screw that up, though. But anyway, Svetlana? Yeah. If you exit the package, there's no way to unimport. Once you've imported a package, it's there. Python knows about it, at least inside the file that you're working with. Okay. Um, no, no. Okay. You have to do that every time you want to use the things that are in that package. And it turns out, even we'll talk about this more, but when you put your code in more than one file, it only knows about the import in the file where you've put the import statement. So if I have code that's in file A, and it has a import sys, and then I call something that's in file B, even though sys is imported, Python has loaded it, the definitions for sys are not available in file B until I do another import sys. So that way, if I had a problem with a conflict where I have two different sets of names or something like that that are in conflict, I can sort of get around that by not using import where I don't need it. Another hand, yeah. Mm-hmm. If B calls a routine that's in A, then sys is defined for any of the routines that are in A. So it's going to resolve it by knowing what's inside the file. It's not going to. It doesn't look outside the file for information. One more hand, yeah. Right. It wouldn't be in this case because I still have a way to get to it. But yeah, delete. I mean, this is declaring a pointer to a package, and if if that's the only pointer, and I get rid of it, I can't access that package anymore. No, you're not. You're not. Well, I guess you might. I mean, if that package created some large memory, some large memory storage, it's possible that it could do that. Right. Um, I think the answer is yes and yes. It's probably using a fair amount of memory, and it probably doesn't matter. um, realistically, if you were, computers have gotten so large, and a computer with a gigabyte of memory is so small these days. You know, you can see. I mean that would be something that if in a very special case you might find that that's true. I can't. I haven't experienced anything like that. The, yeah, you probably can. It depends on. It depends on. I mean, this is getting into operating system specific stuff. But one thing you can do is you can um, go to you look at the image, the task size, which you can do with the top command in either Unix or Mac, or you could go to what is it, Control Alt Delete, that brings up the um, System Manager program in Windows, and look and see what the memory footprint is. But the thing to realize is that these days I mean, it's still amazing to me, we are all running on virtual memory computers. So if there's a section of code that's been loaded in and it's not being used, the operating system has probably kicked it out to a disk for us. So it's probably not doing us too much harm, unless it's really huge. Yeah, Jan. Right, right. Yes. It's convention to put imports at the top of the file, and it's a very good idea because it helps the person reading this file understand what packages are being used, and when something suddenly appears, you know, I'm looking at my code and all of a sudden I see PWLN, I know where it came from. However, there's no requirement that you do that, and you're absolutely right again. This will only get defined when this statement is there. So, you know, I've been known to actually have conditional statements where if something is true, load this package. Okay? You can also, by the way, put this in a try block. Try loading the package, and then you can write your code to run faster if the package is available, but do the computation the hard way if the package isn't available. So you can do things like that, or you can print out an error message. Sorry, I can't run your program because package blah 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 is not available to me. So it is an executable statement like every other executable statement. And there are cases where, well, I'll give you an example. We'll talk about this more, but when I write a module these days, I try to write the module in such a way so that it can be tested. And sometimes I will need modules for testing that I don't necessarily need for running. So I'll only load those modules that I use for testing if I'm testing. Great questions. Okay, so now that I've shown you code that you should use, let me show you some code that I'd rather you didn't use. Okay, and that you'll see it all the time though, particularly in examples. From sys, import, and then I give it a list of things that I want to import. So if I'm only using sys.exit and sys.platform, if I run this, I define platform and I define exit, and I don't need the sys prefix anymore. So matter of fact, it's not even, it won't even be there as sys.platform and sys.exit. Why don't I think you should use this? Well, we had an example a moment ago of somebody asking, well, what about if I use the variable myself? Now, if I redefine platform, I don't have any access to the sys platform. Okay? Also, if somebody else is reading your code, they're much less likely to realize where platform came from, and that it's the system library definition of platform. So I don't recommend this, and I recommend this one even less. This one will bring in everything in my package and make it available to me without the prefixes. And then you definitely have the worry of problems because your package may have something in there that you didn't know about that conflicts with what you've done. So this is a recipe for painting yourself into a corner, I guess I'll say. You'll see this a lot though, particularly in examples. Why is that? Well, in examples you want to make things really compact. You want to make it easy to read. So when people are showing you how to use plot library, they don't want to stick the prefix in front of every routine so it's easy to follow. I personally think it's a mistake. It's even in an example, I would much rather show you that there's a package being used and use an abbreviation for the package name. Yeah. Mm-hmm. Right. Yeah, there is a better way to do that, but you'll have to stay tuned. There's a much better way to do that, but I don't want to go into that right now. But I'll tell you quickly, I guess, that there's a statement you can put into your file that will say, run this code, but only when I'm doing it the way you're describing it, Python followed by a file, but will not run the code if you import it. Okay. Okay, but that's next week. Okay, other modules. Well, if you go to this website here, you'll find references, and this is hard to believe, 14,000 different Python modules that different people have in various different stages. Are all of them useful? No. Are all of them maintained? No. Can you waste a lot of time trying to get somebody else's old module working that hasn't been looked at in 10 years? Yeah. On the other hand, if you can find something out there that does what you want to do, you can save a lot of time too. So this is worth knowing about. If anybody's interested, there's this great lecture that I saw of a guy who used to teach at the University of Chicago showing how to hook up his, I don't think it was a TRS-80, but it was a computer of about that vintage. It was the first computer he got when he was in junior high school, and he was showing it up how to hook it up to the cloud. And he several times went out and grabbed packages out of here that did exactly what he needed, updated them quickly to run in Python 3, and then proceeded from there. And my guess is those packages are now back in here with the Python 3 versions. I think it was Dave Beasley. Okay, so other modules, well, I'm going to talk specifically about these in later lectures. Matplotlib is a plotting package. It's a really nice plotting package. You can use it really easily for doing pretty nice plots. You can use it with more difficulty to do even more sophisticated plots. WXPython. Well, the history of WXPython is that originally, when Windows first started being Windows, it was written on a library called the Microsoft Foundations classes, which not surprisingly only ran in Windows. And people said, gee, this is not a bad-looking way to write graphical user interface code. And some people came up with a cross-platform package called WX Windows. And that ran in C++. And some company, I won't identify which, felt that WX Windows was a little bit too close to their trademark. So WX Windows got changed to WX Widgets. And then finally, some people said, this is really useful. I wish I could use it in Python, and built a set of wrappers around it so you can call that package from Python. And that's what I'm going to talk about for building graphical user interfaces. I've referenced NumPy and SciPy a few times, and I'm just actually writing up the notes on how to use them right now, so that's next week. These are packages for doing very sophisticated mathematics, probably faster than any code you could write in any language you would choose. And CAUtil is a package for getting to epics, and we'll talk about that as well. But it should be noted that there are many, many other packages out there, and you might even have reasons for why you might choose competitors to Matplotlib and WXPython, for example. Yeah? That's a good question. I would say Google is your first choice to see, what's going on. Is there a discussion group related to the package? Who's using it? When you can also look at the package. Where is the package coming from? When was it last updated? Things like that. It depends also a lot on what kind of package it is. Many packages are just simply Python code itself, in which case they're going to be very unlikely to change very much. The things that are more difficult are when you have a package which is partly Fortran or partly C or something like that that needs to be compiled, because then you need to have a different version of the package to run on, whether you're working on a Mac or whether you're working on Linux or something like that. In general, Python has a couple different ways of trying to make that installation easy. But I would say that that's still an unsolved problem. And if it weren't, I wouldn't be recommending, for example, that you use the nthought Python distribution or Python XY. I would just simply go get Python and then get Python to load all these various packages that you need. That's still, I think, one of the problems of Python is that these packages are wonderful, but may not be that easy. If you're writing code and you want to distribute it to run on everybody's computer that's out there, including maybe somebody's VAX, it can be hard to do that if you're going to, yeah. There is a whole, I think it's PEP, but all right. EP, yes, there's a whole discussion process for somebody comes along and thinks Python would be great if it was changed in some way. And actually an example of that is I showed you when I was talking about reading from files that originally if you wanted to read from a file, you had a couple different ways to do it. Somebody came along and said, gee, it would be much more simple if we just set up files to work a little bit differently so that if you open a file and you just simply ask to iterate over it, to do a for loop over it, you just get each line one at a time. It saves a whole call and it's much cleaner, and so that Python was enhanced at some version to do that. So yeah, I mean, the PEPs are out there, and occasionally are referenced in the documentation, rather than somebody saying, okay, here's how it works. They'll simply say, it works the way this description was originally suggested now as a version, 2.3 or 2.6 or something like that. Okay. So packages are simply out there and you don't need to worry about them if the package is a standard package, or if it's a non-standard package and it's been installed in a place where Python's going to look for it. So for example, just to get a little bit ahead, if I want to use matplotlib, all I have to do is to say import matplotlib, because it's been installed for me in a place where Python's going to look for it. But if I write my own packages, or things are not installed in the standard places, I may need to tell Python where to look for that package. And the way you do that is by using this sys.path variable, which is a list. So you can either you can insert a location /user/mylibrary/Python, or C:\\, actually be / my Python utilities or whatever. And when you ask to load a module, it's going to look first in whatever the first element in this list, then the second, until it gets to the ones you've defined at the end. And at that point, it will take the first package that matches what you're asking for. Sometimes you might want to make your package be the first thing to be found, so you can insert it the directory at the beginning of the search path. So you can use either one of these. Again, this is something you won't need until you start defining your own packages or pull in somebody else's. Yeah. Yep. Exactly. So if I am foolish enough to write my own package called sys, and I do this, then you can expect a lot of Python to break as it starts accessing your sys rather than the standard Python sys. So yeah, you can do really strange things, but you don't want to. Okay. All right. So a little bit of homework. This is more of this is a bit of a web searching exercise. Go look at the Python standard functions to see if you can find something that will that will convert something to hexadecimal. And also find the module in the Python standard library that's used to handle dates and times, and write some code that does some stuff to do this. and, and print the times and dates.